Today we are going to be talking about solving systems of equations with the method of graphing. So you may be wondering what a system of equations is. A system of equation consists of don't need the eraser, two or more equations with two or more variables. If you need an example to make that make sense, just look below where it says y equals 2x plus 1, y equals 3x minus 1. So we're talking about grouping those two equations together. The solution, so the answer, what you're looking for, of a system of equations is where the lines intersect, so where they cross each other. And that's going to be your goal to figure that out. So most of the problems you're going to be looking at today, you're going to figure that out by graphing each equation and seeing where they cross. One method of solving a system of equations is by graphing the lines to see where they intersect. And there will be other methods that we explore throughout the chapter, but we'll start with graphing. This first problem actually doesn't require us to graph. It says, is the point 2, 5 a solution of the system? Is 2, 5 where those two equations cross each other? So one way to know this is just plugging that information in, the 2 for the x and the 5 for the y, and seeing if it works out for both of the equations. Is it a solution for both of the equations? So let's try it out. I'll start with the top equation. And again, I'm going to put a 5 in place of the y. And I'm asking myself if this works or not. I'm going to put a 2 in place of the x. So hopefully you can see pretty quick on the right side that 2 times 2 is 4 plus 1 is 5. So I'm getting 5 here and 5 here. So it does work out as a solution of the first equation, but you need to check both equations. So I'll try this one out. 5 in place of y, 2 in place of x. Again, you're asking yourself if this is a solution. Does it work? On the right side, 3 times 2 is 6, minus 1 is 5. So you do get 5, and 5 equals 5. And because it works for both of the equations, it is a solution of the system. So the answer to the question is yes. Be prepared to work with some problems like this that don't actually require you to graph. You're just seeing if that answer works out. Moving on, we're going to actually graph some of these. So number 1, the first equation, I have it in blue here. We're going to graph this. It's slope-intercept form, so I can quickly pick off where it's going to cross the y-axis and what the slope is going to be. I'm going to write that information down. Slope, which is our m, is 2 or 2 over 1 here, so we can think about rise over run. And our y-intercept, which is the b value, is -3. That's where it crosses the y-axis. So the m and b, again, they go along with slope-intercept form, y equals mx plus b. Talking about this and this. So I'm going to graph this. I'm going to go down to a -3 on the y-axis. Put a point there because that's on my graph. Then I'm going to find other points on my equation of my line by rising 2 and running 1. Rising 2, running 1, so on and so forth. And then I'm going to connect them to form my line. It is going to be important for you to try to make as many points as you can because you're not really going to be sure right off the bat where the two lines are going to cross each other. So try to get lots of points so you don't have to make them again later. Now we're going to pick off the information from my red equation. So I'm looking for slope and I'm looking for intercept. So my slope of this equation is the number that sits in front of the x. And we don't see a number, so it's got to be a 1. So my slope is 1 over 1, rise over run. My intercept's going to be a -1. When I come over to graph it on the y-axis, I'm going to go down to a -1. then I'm going to go up 1 and over 1, and up 1 and over 1, and up 1 and over 1, and up 1 and over 1. And you can see pretty quick where these two equations are going to intersect one another. Right here. And so my solution of my system of equations, the ordered pair, will be 2, 1. If I was to test it and plug in my x value is 2, my y value is 1 into each of the equations, kind of like we did that last problem, it should turn out that it is a solution for both of those. So this is what you're going to be working on most of the hour today, is just practicing graphing again and then seeing where your two equations will cross each other. And that's the solution of your system of equations. Let's try out some more problems. Again, I need to identify slope, intercept. So my slope in the blue equation is going to be 1 over 1, rise over run. My intercept is 5, the number on the back. I'm going to start by plotting that point up at positive 5 on the y-axis. And then I'm going to use the slope to find other points. So my slope is up 1 over 1, up 1 over 1. I'm also going to go backwards. And I'm going to go ahead and graph the next one. Slope here is a negative 4 or negative 4 over 1, rise over run. My intercept, you don't see anything added or subtracted, so you can think about it as being like adding 0. That means on the y-axis, it's right at the origin. That says I need to go down 4 and run once. And you can see I'm moving away from my blue line, so I'm going to have to use some skills to go backwards to figure out where it crosses. I think I'm going to add one more point down here in the corner, though. It's a fairly steep line. It looks like they intersected right there. So the solution of the system should be at the point negative 1, 4. This would be your answer. I'll also be looking for your graphs. Let's go ahead and do another problem. Again, it helps if you identify the slope, the intercept. So the slope here is a negative 1/2, rise over run. The intercept is at 2 on the y-axis. Go up to 2. And I'm going to use the slope to find other points. So it says go down 1, negative 1, and then run 2. Down 1, run 2. Also go backwards. My second equation, slope, is negative 3 or negative 3 over 1, rise over run. My intercept is a negative 3, so I'm going to go on the y-axis down to a negative 3. Then I'm going to go down 3 into the right 1. I'm also going to work up backwards. And I'll remember to connect my lines to show that it's line. And I found my solution is at -2, +3. So moving on to the next side of your note sheet, you'll see that there's a couple word problems here. I'm going to do one of these word problems, and then we'll pick up the rest the next time we have class. So we'll try out number 4. So suppose you plan to start taking an aerobics class. Non-members pay $4 per class. So that looks like some important information. While members pay $10 for this fee, and then they also have to do plus $2 per class. So they have to pay some money up front, and then they have a smaller class fee of $2. First says, write a system of equations and solve by graphing. What does the solution mean? So we'll start with non-members. We have to come up with an equation that goes along with how much the non-members have to pay, so like the total cost. I'm going to have some variables over here. We'll say y is total cost. So y equals, and then x, think about what that would be, what that variable should represent. So what's changing every time? The number of classes that we're going to. So x is going to be number of classes. So my non-members, their total cost, y, is going to be equal to $4 per class. So we'll take $4 times however many classes they have, 4 times x. Then let's see if we can come up with an equation for our members. My pen will work. So our members' total cost, y, is going to be equal to, let's see what it says. They pay a $10 fee to be a member, and then they only pay $2 per class. So they have to pay that $10 fee up front. And then we're going to add on $2 times however many classes we take. So 2 times x, because x represents the number of classes. Now we're going to solve this by graphing. X is the number of classes. I'm going to label that down here where my x-axis would be located. Y is the total cost. And we'll start with 0 in the corner. Number of classes, I'm going to tell you don't have to go out very far. Maybe let's go out to 5 or 6. And then think about how the cost is going to go. So for non-members, the cost is going to increase each time by $4 depending on how many classes you have. For members, they have to pay the $10 up front, and then it's $2 per class. So I'm thinking a good scale here. I'm not going to want to go by ones. That's going to be too small. Let's do 2s. Let's go ahead and label that. We're going to do the non-members in green. So if you think about the slope and the intercept here, the slope is 4 over 1, and the intercept is 0. So if they don't go to any classes, they don't have to pay anything because they're not a member. So I'm going to put a point down here right in the corner at 0, saying they went to no classes, they paid nothing. Then let's say they've gone to 1 class. Well, 1 class costs $4, so I'm going to put a point at 1, 4. If I go to 2 classes, 4 times 2 is 8. So I'm going to go up to 2, 8. If I go to 3 classes, I'm at 12. 4 classes, 16. 5 classes, I'm at 20. 6 classes, I'm up at 24. And I'm going to connect those so you can see the trend. I'll do members with a black line. So their slope is 2, or 2 over 1. And their intercept is 10. So even if they don't go to any classes, because they're a member, they have to pay $10. And then if they go to 1 class, they pay $10 plus the 1 class fee, which is $2, so we'll add that on to get 12. Or essentially I'm going up to, remember my scale is going by 2, so I'm going up 2 and over 1. And then if I go to 2 classes, it's 14, 3 classes, 16, 4 classes, 18, 5 classes, 20, 22, 24, so on and so forth. So I'm going to connect those. So you can see where they cross. So our solution is 5, 20. Question also asks, what does the solution mean? So if this is where the 2 plans cross each other, where they're equal to each other, it must mean that for 5 classes, it costs $20 for both of the plans. So it doesn't actually matter what plan you're on. If you're a member or a non-member, you're going to pay $20. If, for instance, you only wanted to go to 1 class, think about which one is going to be cheaper. Is it going to be cheaper for me to be a member, the black line, or is it going to be cheaper for me to be a non-member? And in this case, it's going to be cheaper for a non-member. But if you're planning on going to more than 5 classes, like 6 or 7 classes, whatever the case is, it looks like that's when it's really going to pay off to be a member, because non-members are going to have to pay a little bit more. That is going to conclude the video on the first half of the 7-1 notes on solving systems by graphing.